Good evening. Today's topic of discussion is regulation of respiration. Regulation of respiration. So, regulation of respiration is uh, divided in two parts, that is neural regulation and chemical regulation by chemoreceptor. In neural regulations, we have brainstem that contain vital center for homeostasis or physiological characteristics of our body. The brainstem has two parts we know, that is midbrain, pons and medulla. In medulla there is a neural area that is called pre-Botzinger complex. This is the pacemaker of respiration. It means it causes automatic control of respiration. Medulla also contain dorsal respiratory group of neuron and ventral respiratory group of neuron. Dorsal respiratory group of neuron control respiration. Ventral group of respiratory neuron causes control inspiration as well as expiration. Now, dorsal respiratory group of neuron function is it helps in normal quiet respiration, and ventral group of respiratory neuron, whenever there is increased requirement, that is during exercise, it activates. Now, this dorsal respiratory group of neuron gives positive stimulus to pharyngeal nuclei. From pharyngeal nuclei there is contraction of diaphragm causes normal respiration. Now, the pons. The second part is pons. It has two centers. One is pneumotaxic center, another is apneustic center. Pneumotaxic center and apneustic center help in control of depth of our respiration. Apneustic center causes increase in depth of respiration, but pneumotaxic center causes decrease in depth of respiration. Also, the vagus stimulus, that is stimulated by pulmonary stretch receptors, causes decreased depth of respiration. When there is increased pulmonary stretch receptors activation, vagus activate, and that vagus causes decrease in depth of respiration. Now, these centers, this is pneumotaxic centers and apneustic centers, help in smooth transition between inspiration and expiration. Also, these centers control depth of respiration. Now, the cortex, this is the higher part which is responsible for voluntary control. Now, what will be the effect if we do transaction at various level of our respiratory center? If we do transaction between midbrain and pons, that is the cortical control will loss, so the loss of voluntary control of respiration will occur. If we do transaction between at the mid-pontine level, that is between pneumotaxic and apneustic center, there is increased depth of respiration because the negative effect over the apneustic center will go on, that will causes increased depth of respiration. If we do bilateral vagotomy plus mid-pontine segment, that is there will be no negative regulation of depth of respiration, so there will be prolonged inspiratory spasm. That prolonged inspiratory spasm is called apneusis, also known as apneustic breathing. Now, if I do transaction between pons and medulla, that is the smooth control of respiration will gone, leading to irregular and gasping type of respiration. Now, if we do transaction below the medulla, there is will be loss of respiration or loss of regulation of respiration or cessation of respiration, that is called apnea. Now, the chemical control, it occurs by chemoreceptors. It control rate and depth of respiration. We have two type of chemical receptor, is peripheral, others are central. Then peripheral chemoreceptors has two parts, carotid body and aortic body. Carotid body usually present at the bifurcation in the carotid artery, and it signals is transmitted by ninth cranial nerve, and aortic body signals is carried by 10th nerve. The stimulus for chemical center or chemical receptors are PCO2, PCO2, H plus, pH, lactic acid, potassium. Decrease in PO2, it is the most potent stimulus for peripheral chemoreceptor, that is carotid body and aortic arch. In case PCO2 also stimulate these centers. Now, the chemical chemoreceptor, chemical peripheral chemoreceptor, that is carotid body and aortic arch. Carotid body is 5 times more potent or more sensitive than aortic body. Carotid body is more sensitive than aortic body. Now central chemoreceptor, it is on the surface of the medulla. The most potent stimulus is PCO2. So what happened here? This is the medulla, and if this is the blood vessels, there is a junction that is called blood-brain barrier. So PCO2 will cross the blood-brain barrier, and here in CSF the PCO2 will be converted to bicarbonic acid, that is divided into H plus ion and bicarbonate ion. That H plus ion causes stimulation of the central chemoreceptor. So the potent stimulus for central chemoreceptor is PCO2, but the potent stimulus for central chemoreceptor in CSF is H plus ion. Now, depending on these centers, we have various types of respiration. One is normal quiet respiration. If we plot the depth and time in various axes of our graph, if we see, this is the normal quiet tidal volume and this is the normal respiratory pattern, and it is controlled by our respiratory center. Biot's respiration, it is the depth of the respiration will be same, but the pattern will be irregular and there will be variable period of apnea. It occurs due to injury to the medulla, lead to abnormal pattern of respiration. This type of abnormal pattern of respiration, that is called Biot's respiration. Now the apneustic breathing. Apneustic breathing means mid-fontanine section, that is between pneumotaxic center and apneustic center, plus bilateral vagotomy if occur. In those situations, or if injury at the mid-fontanine segment occur, there will be prolonged inspiratory spasm, that is called apneusic or apneustic breathing. Now ataxic or irregular breathing. Section below or section between pons and medulla. As we know, the pons causes smooth transition between inspiration and expiration. So there will be no smooth transition. Expiration and inspiration will occur in haphazard manner. This is called ataxic or irregular breathing. The next pattern is acidotic breathing or Kussmaul breathing. During acidosis, there will be increased H plus concentration in our body fluid, in blood as well as in CSF. That will causes stimulation of the chemical receptors, that is central as well as peripheral. That lead to increased rate and depth of respiration. So rate will be increased and the depth of respiration will be shallow, that is called rapid shallow breathing. It is also called Kussmaul's breathing. Rapid shallow breathing, that is called Kussmaul breathing. The next pattern is Cheyne-Stokes respiration. The Cheyne-Stokes respiration, there is hypopnea followed by hyperopnea followed by apnea. So this is hypopnea, hyperapnea, there is apnea. Why this thing occur? The loss of neural control will occur, then the chemical control will be the only respiratory control. PCO2 retention will occur as there is no respiration, that lead to increased depth and rate of respiration. So due to increased rate and depth of respiration, there will be PCO2 washout. This PCO2 washout lead to cessation of stimulation of the respiratory center, lead to apnea. This apnea will again causes increased PCO2 retention. That PCO2 will activate the central chemoreceptor, that lead to increased rate of respiration. That is called Cheyne-Stokes type of respiration. Then there is an cards, that is called Ondine cards. In Greek mythology, Ondine was a character was caused by loss of all automatic function. Loss of all automatic function. So he was lost automatic respiratory regulation. So, but he was alive because he was able to do respiration by voluntary control. But when he goes into sleep, that voluntary control goes, and voluntary control goes, and Ondine died. So loss of automatic control of respiration is called Ondine curse. Thank you.